Okay, I've turned the video or the recording on, so we're live. Let me go over a couple different announcements. Welcome to E-Period Algebra 1. It's Thursday, May 14th. 7 days from this moment will be your last class in Algebra 1. Unless you begin next year in summer school. But hopefully it's your last class a week from today. All right. Couple of announcements. You know by now, if you miss class, you lose 45 points of your rep grade. You can salvage 10 points of them if you check in during office hours, at least one time during the week. Just 2 to 2:30 Monday through Thursday and 9 a.m. to 10 a.m. on Friday. And if you recall, on Tuesday, we wrapped up section 6-2, which was solving systems of equations using substitution, with doing problem set 2 collectively in class. That wasn't due, and I don't believe I loaded it on Blackboard, but I did load section 6-2 quiz on Blackboard. And out of the 12 of you, a grand total of 1 had it submitted by 9 a.m. today. So I'm not sure where the other 11 you knuckleheads are, but you might as well turn it in late. You're going to lose a few points for not turning it on time, but it's there on Blackboard, ready to go.
Wait, what were we talking about again?
I'm talking about Algebra 1. What are you talking about?
You said something was due at 9. You were talking about the quiz, right?
I didn't understand that. Sorry.
The quiz was turned in this morning, right?
Section 6-2 quiz was due 4 minutes ago, and as of 4 minutes ago, only one person had submitted it.
I submitted it. What? I turned it in to you. Remember?
No, you didn't. When did you turn it in, and where?
Obviously, I turned it in 2 days ago, and that's on my life.
You might want to resubmit it. I'll go back and check. And it's not Dropbox. I can tell you that because I just dumped Dropbox. It's not in Dropbox.
What did you get?
I can't use Dropbox. The Dropbox doesn't work for me.
Whose did you get?
Yours, Mr. Hughes. You're the only one.
Thank you. I bet.
Good job,
Okay.
Josh.
Hughes is on top of it. He's
Thank you, Owen. Love you, man.
conscientious about getting his work in on a timely basis. Okay. That being said, we are moving on to section 6-3. Okay. And we're going to solve, if you recall, on last Thursday and Tuesday, we were solving systems equation using substitution. We substituted something for something, so we took those two equations and we created one equation with one variable. All right. And then you're going to learn another way of solving this. It's solving systems of equation using elimination. So we're going to do exactly like it tells you to. We're going to eliminate one of the variables. We can do so by addition, subtraction, or multiplication. I'm going to use a Patrick JMT video because he's got a nice little 8-minute video. All right, so you may want to have pen and paper handy to take a few notes. And he's going to kind of give you a brief review of graphically solving systems of equations. And then he's going to do show you how to do it using addition. And we're going to get through addition today. We may even start using subtraction. All right. Any questions before I get going here? Any questions? All right. So let me load this up. Give me 1 second. All right, have pen and paper handy. You may want to take a few handy dandy notes. All right, so here we go.
All right, in this video, we're going to talk about solving systems of equations, but this time we're going to...
Everybody hear the sound okay? Give me a thumbs up.
Yes, sir.
Excellent.
use the method of what's called elimination by addition. And again, as I talked about in the last video, or the one that uses substitution, we're graphing, you could graph these linear systems of equations, and one of three things is going to happen. Either the lines are going to cross in one place, okay, that means you have one solution, and eventually you'll be able to do some algebra to where you'll get x equals some number, y equals some number. The other thing that could happen is the lines could be parallel, and eventually you'll get some sort of nonsensical statement like 8 equals 0, and while that never happens, and what that's indicating is that your lines are parallel, which means that, and in this case they're parallel and non-overlapping, so that there's no solutions. The last thing that can happen is you'll end up doing some algebra and you'll get a statement like 0 equals 0, or 12 equals 12, or 5 equals 5. And what that means is really it's just the exact same line. Maybe it looks a little different, but algebraically it's the same line, which means they're overlapping, which means there would be infinitely many solutions, because everywhere they intersect you get a solution. So let's do a few examples here talking about this elimination by addition. And the numbers I'm going to use are going to be hopefully, fairly straightforward, just to keep the arithmetic to a minimum. But obviously you could use these ideas whether you've got fractions or decimals or any other kind of strange numbers floating around, if we can call them that. So the idea is, what you want to do is you want to basically, eliminate a variable by doing addition, or equivalently you could do subtraction. Notice here that I've got a positive 2x and a negative 2x here at the beginning. And what I'm going to do is I'm just going to think about everything. Notice too, everything's lined up. I've got my x's, I've got my y's, I've got my numbers. I'm just going to simply add up everything in each column. So maybe I can even put it in parentheses and put a little addition out here. So 2x plus negative 2x is 0x. 3y plus 7y is 10y. And then 4 plus 16 is 20. Well, 0x is 0, so we're left with 10y equals 20. We can simply divide both sides by 10, and we'll get that y equals 2. And just like in your procedure when you did substitution, now you can use either one of your original two equations, and you simply plug in the fact that y equals 2. So I'm going to use the first one. So it says you'll get 2 times x plus 3 times y, but here we're plugging in again the fact now that y is equal to 2 equals 4. So I'm just using this first line. And now I'll get 2x plus 6 equals 4. Okay, I can subtract 6 from both sides. 4 minus 6 is negative 2. If I divide both sides by 2, I'll get that x equals negative 1. And these are my solution. This is my solution to this system of equations. It says you're going to have a solution of negative 1, comma 2. Negative 1 for x, 2 for y. And the idea is you can plug negative 1 in for x, 2 in for y. In the first equation, you'll get 4. And the second equation, you'll get 16. Again, graphically, if you were to put these lines on a graph, you would find that they're intersecting at the point negative 1, comma 2. All right, so there's one example. We'll do a few more here. Notice in this one, if I kind of immediately do my addition, nothing is going to cancel out. The x's wouldn't cancel. I would actually get a negative 6y. And we need one of the variables to be eliminated. So what I'm going to do is, notice if I multiply everything in the second row by a negative 1, well then my y's would cancel out. So I'm going to leave my x minus 3y equals 6 part alone. And then I'm simply going to multiply the first one, or excuse me, the second line by a negative. That'll give me negative 4x, positive 3y, and negative 10. I could have easily, multiplied the first row by a negative. So, all you have to do is just change one of them. So it doesn't matter which one you do. So if I do my addition now, x plus negative 4x is going to be negative 3x. My y's are going to cancel out, and then I'll get 6 plus negative 10, or 6 minus 10. That'll give me negative 4. I'll divide both sides by negative 3, and that'll give me x equals 4/3. All right, so not a nice whole number, but who cares? So again, I'm now going to take my first equation. I usually just pick the one that has the smaller numbers floating around. I figured that's going to make my arithmetic easier. I'll plug 4/3 in for x. Then I have minus 3y equals 6. So I have to subtract 4/3 from both sides. So I'm going to go right, 6 is 6/1, and then I bring over my minus 4/3. And again, I'm writing 6 is 6/1 because I'm going to have to get common denominators. So I could multiply top and bottom of the first fraction by 3. That'll give me 18/3 minus 4/3. Whoops, let me squeeze that back in there. So I've got negative 3y. 18 minus 4 is 14/3. And then I'm going to multiply both sides. I'm going to divide by negative 3, which is equivalent to multiplying by negative 1/3, right? The negatives will cancel, the 3's will cancel. But that means I have to multiply the right side by negative 1/3 as well. So I'll get y equals, and remember with fractions, you just multiply across the top, you multiply across the bottom, and again, now we've got our solution. It says our solution is going to be 4/3, as we found for x, and negative 14/9 is going to be our y value. Okay, so this is why I think either using substitution or this elimination by addition is preferable, because you know, unless you're a great artist, I don't know if that I would be able to graph these original two equations and somehow tell that they're actually crossing at 4/3 and negative 14/9. A calculator is going to give you a decimal, and a lot of times, even still, it seems like they give you the wrong answer. They'll give you some kind of weird answer, so got to be careful about that. Let's see if we can't squeeze in 2 more here real quick.
All right. So that's, if you ever are working on these and you run into a snag or a problem, this is a counterpart or comparable to Khan Academy. It's called Patrick JMT. Just Google Patrick JMT. That's going to give you a bunch of YouTube sites, but go to patrickjmt.com, and it's got a search bar at the top, and you can type in anything that's on the top of your problem set for those, and then he'll have a couple to a handful of videos on that. And I don't know about you, but I kind of like that. He's a little simpler to follow than Khan Academy. It's kind of like, you know, he's left-handed. You're kind of looking over his right shoulder. He explains it very clearly and concisely. His handwriting is phenomenal, and it's kind of like how you would crank it out. So use it as a resource. He's got algebra, he's got geometry, he's got pre-cal, he's got calculus. Not quite as extensive as Khan Academy, but pretty darn close. All right, so I'm going to pull up section 6.3, problem set 1, and if you got pencil and paper handy, we should be able to work through a couple of the problems. And I'll have them loaded on Blackboard at the give me about 15 minutes after class is over, and I'll have the problem set loaded on Blackboard. All right. So let me do, let's see. Let me see if I can find it. I think that's it. Okay, let me move things around here and get it so it's a little more legible. Okay, so this is, let's got that garbage on. Let me eliminate the garbage. I'm going to do that. There we go. All right. So here's what problem set, this is 6.3, problem set 1. solving system equations. This first problem set's using addition, so it just knows you're going to add something to eliminate something. The second problem set, I'm going to load them both on Blackboard, is using subtraction, so that it's going to tell you real quickly on the problem set what you got to do. You got to eliminate, and you're going to eliminate using addition. So it's there's your roadmap right there. All right. You've got two fine examples there that I'm not going to walk you through. Just use those again, kind of like Patrick JMT. Just use them as a reference. All right. Give me a second, see if I can get this to scroll up. Any questions before we get rolling here? All right. So I've got things kind of lined up like he did. They're fairly lined up, but it's a little juggling act when I formulate these problem sets. So we're doing addition here, right? So it's already telling you what to do. And if you look down the line, like he said, the x's and the y's and the constants are all lined up. And you can see I got a positive y and a negative y. So anytime I have a kind of opposing variable with the exact same coefficient, but opposite signs, by adding is going to eliminate. So if I go x plus x, I get 2x, right? And if I go y plus negative y, that cancels out, or I got 0y. I'm not going to write that just for sake of clutter. I got -4 plus -2 is -2, right? And just like he did, we're just going to divide both sides by 2, and we get x equals -1, because -2 over 2 is -1. All right. So now I can take that x and I can put it either in this equation or that equation. Doesn't matter. And I'm going to pick the top one, and it doesn't matter, but I'm going to pick the top one because it's got a positive y instead of a negative y, and I won't mess up maybe that negative y. So now I've got -1. We're solving for y, not negative y, so it also saves a step. So we got -1 plus y equals -4, right? And so we're just going to add, -1. Correction, we're going to add 1 to both sides to get that -1 over on the right side of the equation. So we add 1 to both sides. It'll zero out the 1 on the left side, and +1 plus -4 equals -3. All right, so now we know these two lines intersect, and they have one point in common, and it's -1. Always put it in an ordered pair for your final answer. -1, -3, right? So if I plug in -1, let me erase a couple things here. If I plug in, there we go. If I plug in -1 here and -3 here and -1 here and -3 here, this side in equation 1 is going to equal 4, and this side in equation 2 is going to equal 2. Right? Does that make sense? Pretty straightforward. And like I said, the instructions actually tell you what to do. All right, so grab your pencil and paper, all right, and we're going to solve these using addition, all right? And you can see what just the way things stack up. There we go. We got a variable there with the exact same coefficient and with opposite signs. And so when I add those two together, it's going to zero out or cancel out that variable. So just take a minute, and I'll give you 90 seconds to work it out. And let me know how you did.
Mr. Gaffney,
Yes, sir.
should we be writing these down? Is this going to be like homework?
Yeah, it's homework. So you're going to have, yeah, I think twice already I've said for a third time, you should have pencil and paper there in front of you, and you can knock out, I think there's 14 problems or so on this. We can knock out 4 or 5 of them right now, so you're going to have, 8 or 9 to do, right?
Mr. Gaffney,
Yes, sir.
I'm not gonna be able to print this out, so I'm gonna have to write it down. But I'm gonna have multiple sheets of paper, so I'm gonna have to email it to you.
Okay. Don't do it as a video.
Yes, sir.
I can't grade videos. Sometimes I can do stuff fast, but not that fast. All right. You got it done? So hopefully you ended up with if we add these, you ended up with 3x equals 3, right? And so we got x equals 1, because we're going to divide both sides by 3, right? And then we're going to plug 1 back into either one of these two equations, all right? I'm going to pick the second one this time, because again, it just looks simpler, but it makes no difference. Do the one that looks like the math for you is going to be simpler. So then I get 1 plus 3y equals negative 11, all right? And if I subtract 1 from both sides, it'll cancel out that 1 on the left side of the equation, and I get negative 3y, not negative 3, I get positive 3y equals negative 12, right? So I subtracted 1 from both sides, and if I divide both sides by 3, I get y equals negative 4. I know that doesn't look like a y, but it is. So our answer is 1, negative 4. These two lines intersect, and the one and only point they have in common is that point over 1 down negative 4. Any confusion? Pretty straightforward, right? We can only solve for one variable at a time, so we got to eliminate one, which is the name of the section, elimination. So we're going to eliminate 1, and we're doing it by either addition or subtraction. And this problem set number 1 is by addition. So addition and elimination, it tells you exactly what to do. Okay, number 3. Add these two together. I'll give you 90 seconds. Give it a shot, and we'll talk about the answer here. Okay. You got, if you're lost or you have if there's any confusion, ask me. Okay. Anybody done?
Wait, what happened, Mr. Gaffney?
So is anybody done?
No.
Another 30 seconds. All right. You should have. Tell me the answer. Anybody?
Y equals negative 9 for the y-intercept.
We're not doing y-intercepts. We're doing where the lines intersect. You should have gotten negative 2, 3, right? If I add these two, this goes away, right? If I add the y's, I get negative 3y equals negative 9, right? If I divide both sides by negative 3, I get y equals 3.
Amazon.
Bada bing, bada boom, right? Now, if I plug 3 into, I'm going to pick the top equation because it doesn't have as many negatives. I get 3x minus 3 equals negative 9, right? Now, if I add 3 to both sides, I get 3x. That'll remove the 3 on the left side equals negative 6. If I divide both sides by 3 now. I get x equals -2, which corresponds with the answer up on the top of the equation. Make sense? Questions or confusion? Anybody lost? Don't be bashful. All right. Okay. I don't mind if you guys don't have a printer at home, you can just hand copy the problems off a Blackboard. I'm not going to do any more of these. I'm going to let, if you want to, let's see. There's 2 word problems at the end. I'd love what you're going to use. You're going to use addition elimination to solve. So it's not anything different than what you're doing. But I'll leave it. If you talk over me, I can't hear you. But I'll leave the screen up for about 90 seconds if you want to copy any of these problems down to be a little bit ahead of the game. And then we're going to go to elimination using subtraction here with problem set number 2. Someone was talking over top of me. I can't imagine who that was, but if you've got a question, you can talk now. I'll put a few little clues on here for you, just kind of hop skipping around.
Mr. Gaffney,
Yes, sir.
I just sent you my quiz again, like not too long ago.
Okay. How are we doing? So if you just want to copy it down instead of having it printed out.
Why are you putting arrows on those?
The arrows indicate what you're going to eliminate, right? By adding.
Oh, okay.
Just kind of follow the yellow brick road. 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 I think there's a movie with that in it, right? Follow the yellow brick road.
So it's just you're adding.
Follow the yellow brick road.
It's just you're adding or subtracting like the same. It's the one you add or subtract the one that's like the same number.
All right, one more time. We are going. All these on this problem set, you're going to solve by addition. So there's no mystery in what you got to do. And when I add the same variable with the same coefficient, which is the number in front of that variable, that have opposite signs, when I add them together, it's always going to zero them out. And that's the goal. I need to limit. I can't solve for 2 variables simultaneously. I only can solve for 1. All right.
So what if it only has one sign?
Pick which one are you talking about so I can address it specifically.
Number 4.
Number 4. What do you mean it only has one sign?
Like the top one has a -3, and then the bottom one just has a 3.
Right, just because they cancel out.
So if it doesn't have a sign, what is it?
Positive.
Negative.
Bada bing, bada boom. If there's nothing in front of the number, it's positive. Right? Does that answer your question, Mr. Martin?
Yes, sir.
All right. Everybody copy all those? I got them down, those that want to copy them and not print it out. All right, let's look at one of these just to kind of, let's see here. So we're going to use addition elimination to do this, all right? All right, Rima is older than Ken. The difference of their ages is 12. The sum of their ages is 50. All right, so let's make Rima X. Let's make Ken Y. All right. So the difference of their ages is what? X minus Y, difference, equals 12. Bada bing, bada boom. The sum of their ages is 50. X plus Y. All I'm doing is I'm taking this verbal statement and I'm making an algebraic equation. All right. Right? So that looks remarkably familiar to those previous 12 problems. I'm going to add, I'm going to eliminate the y's, and you take it from there. All right. So I'm going to let you go from there. Take it. All right. Are we good? Any questions before we slide over to solving systems of equations, not with addition, but with subtraction? Any questions? So I'm going to have two problems. I'll probably have two entries. I'll have two entries for today. I will have I'll have problem set 1, which will be addition. Problem set 2, which is addition, which is subtraction. Okay.
Mr. Gaffney,
Yes, sir.
so the two X's, they combine, right? Because they're the same sign, right?
So what's X plus X equal?
2X.
Bada bing, bada boom. What's negative Y plus Y equal?
It cancels out.
Cancels out. So that's you eliminated it, right? 12 plus 50 is 62. So X equals
31.
31. So Rima is 31. All right. So now I'm going to go back and I'm going to take this 31 and I'm going to stick it right in this equation here. All right. So I get 31 plus, I use that because I didn't want the negative Y, equals 50, right? And if I subtract 31 from both sides, I get Y equals what?
19.
19. So Ken is 19. Bada bing, bada boom. All right. So that's that one. Okay. Questions before we now do subtraction? So it's the exact same thing, but instead of adding to eliminate, we're going to subtract. This is pretty straightforward. Let's see here. I want this. Give me a second. Actually, give me 1 second here. Get into this. Give me 1 second. 6-3, number 2. Let's see. Now let me try some. Bear with me. Let's see if it's up there now. Share. 6-3, number 2. Where is 6-3, number 2? There we go. Okay, so there's number 2. So it's telling you, no surprise here. Instead of addition, we're going to use subtraction. And we're still eliminating something. Okay. I won't walk you through the example. Use that as a reference. Okay. So let's look at these. All right. So I'm going to do something slightly different from what Patrick did. All right. So we're doing subtraction. remember what he was using addition, so he multiplied some of those bottom equations by -1. All right. I'm surprised he didn't mention it, but he could have just used subtraction, but I know that exercise he was doing was addition. So I mean, it's kind of two different ways to skin a cat, right? So I got identical 6x's. So the only way I can eliminate one of them is subtract. So 6x minus 6x zeroes out. 0x, right? And now be careful with the negatives. I got 5y minus a -7y. So what am I really doing for this part of the problem? What does 5y minus a -7y equal? Anybody?
-2y, 12y.
Bueller. 5y minus a
Oh, minus.
y is the same as, I got a double negative, so I'm now adding, right? So then I got 4 minus a -20. What does that equal? 4 minus a -20.
-24.
What kind of 24?
Negative.
What kind of 24?
Negative.
What kind of 24?
Positive?
There we go. 4 minus a -20 is the same as 4 plus 20, right? Double negatives, double negatives. Be careful, be careful.
What's on the left side of the? Oh,
Again,
oh, sorry, sir.
divide both sides by 12. I get y equals 2. All right, I'm going to substitute that y in the first equation for 2. So I get 6x plus, I'm going to multiply 5 times 2 to save me scribbling, is 10, right? Equals 4. You see what I did? I just took the first equation. I took this 2, stuck it right there, because that's 5y is the same as 5 times y, right? I'm going to subtract 10 from both sides. Subtract 10 from both sides, so 4 minus 10 is a -6, right? And I divide both sides by 6, and I get what? X equals -1.
1.
All right?
Mr. Gaffney?
So my ordered pair is for where these two lines, this system of equations, where these two lines intersect is -1. Yes, sir.
What is under the line to the left of the equation?
Right here.
Yes, sir.
What does 6x minus 6x equal?
So it's 0? Oh, yeah.
0x. All right. Questions on that guy? You know what I'm gonna do? I'm gonna make a correction. I'm gonna load this on Blackboard, but I'm gonna combine problem set 1 and problem set 2 into one document. Okay, it's gonna be one document, so it's gonna be 4 pages. All right. I don't see you again for 5 days. We're gonna work through several of these, and there's about 12 problems on each page. We already did 3 on the first one, so that's 9. We'll do at least 3 of these. So it'll only be 18 problems. You can do 18 problems over 5 days. Okay. We are subtracting. There's a setup. I want you to solve this one. And follow the yellow brick road. Okay, you do it. I'm going to give you 1 minute, 1 second to do it, and then I'll put what you hopefully did.
Sir, I don't see the problem sets on Blackboard.
You know why?
Has he didn't put them up yet?
They're not there.
Okay.
I told you. I'd give me about 20 minutes after class is over and I'll load them up. All right, we coming along? We're subtracting.
What?
Mr. Gaffney, I emailed you my quiz.
Better late than never.
I also emailed you the 6-2 problem set 1 that I was missing.
Okay.
M equals -2. Answer.
All right, should have come up with -2, too. Right? Why is it -2 and not 2, -2? Which letter comes first in the alphabet? M before N. Questions? Questions?
Wait, what was the alphabet thing, sir?
A, B, C, D, E, F, G. Which letter comes first? M or N?
Sir,
M or U,
English.
S-E? What?
This is math. This is algebra,
Who's your English teacher? Lowry?
sir.
Oh my gosh. Ooh. Okay, let's do this one, and then we'll probably call it quits. Follow the yellow brick road. Follow the yellow brick road. Follow the yellow brick road. Follow the yellow brick road.
So you said whichever variable comes first, you do first. Right? Right, Mr. Gaffney?
I'm sorry, say it again.
Whichever variable comes first, you do first.
I'm not sure if I follow your question.
Like A comes before B, so I would solve
yes.
it first.
Always. A, B, C, D, E, F, G. God, you're killing me.
That's my favorite song, sir.
M-O-U-S-E.
Sir, that spells mouse.
Okay, there's number 3.
This is difficult, sir. This is nowhere near close to the alphabet.
What? Adding 1 plus, what's difficult? Adding 1 to both sides of this equation? What part is difficult?
I don't know. I just
Coming
make it,
We're coming
like
up,
you said, sir, always make it harder than it needs to be.
I know that 1 plus -1 and 1 plus 3, we're pushing the envelope there. We're pushing the envelope. All right. So the moral of the story, you knuckleheads that couldn't submit the quiz, couldn't complete the quiz in 5 days, make sure you submit it. You'll lose some points for not following instructions. All right. Give me about 15 or 20 minutes, Mr. Martin, and I will load this. I'm going to combine these 2 problem sets as one. And on Blackboard, okay? I'm not going to have you put a Dropbox. You don't have to turn them in, all right? But you should do them because we're probably going to have a quiz on this on Tuesday, all right? So if you don't do them, I'll figure that out when you do the quiz, all right? So,
Don't do what? These problem sets?
no, don't do them. You know, we're just here for the heck of it. We're just killing time.
No, sir, because then we're gonna have a quiz, and then you know that I didn't do them.
Exactly. Exactly. And since only 1 out of 12 of you could submit the quiz, you know, I'm not gonna worry about you doing the problem sets. My recommendation is for you to do them so that when we quiz on this on Tuesday, you do well. If you don't do the problem sets, then you'll be lost in the sauce, as a previous master sergeant here at Benedictine used to say. All right. Questions about anything? If you missed a class this week or you want to pick an extra 10 bonus points up, 2 to 2:30 today or 9 a.m. to 10 a.m. tomorrow. All right. Everybody have a wonderful weekend. And I'll see you in about 5 days next Tuesday at 9 a.m. bright and early. Last call for questions. Last call.
Wait, what's happening at 2:30 and then 9 a.m. tomorrow?
Office hours are 9 a.m. to 10 a.m. on Fridays, 2 to 2:30 Monday through Thursday.
Oh, okay.
Okay. And it'll be that way next week too.
Sir, did you want me to stay in here?
Yeah, I want you to stay in your room all day. You can't come out.
Okay, so you want us to do the problem sets you just gave us, but we don't have to turn them in, right?
Exacto mundo.
Okay, thank you, sir.
All right. Way to go.
And I still have to turn
Tiger
in.
King.
What?
Way to go, Tiger King.
Yes, sir. And then I still have to turn in the quiz from this morning.
Unless you want to just keep it as a 0.
Not really, sir.
You're going to lose points for not following directions. I mean, I know it's a lot to ask you to do a 12-question quiz in a 5-day period. Ooh.
I'm sorry, sir. I've been working.
Hey, we all got priorities. I can understand that Algebra 1 is not one of yours. All right,
Sure.
here we go. We're at it.
I love your class as much as anybody else's.
I don't know if that was a good compliment or not. All right.
Mr. Gaffney?
Okay, sir. Goodbye, sir. Have a
Mr.
nice day.
Mr. Hunter.
Yes. Mr. Hunt, I mean, Mr. Gaffney.
Mr. Hunter.
Mr. Gaffney, can I ask you a question?
You just did, but go now. You can ask a second one.
All right, bet. What are we supposed to do again? My bad. I forgot.
I'm going to load these 2 problem sets as one on Blackboard in about 15 minutes, and you're going to use.
Can you email it to me?
Send me an email.
All right, bet. I just sent you my quiz, by the way, again.
Well,
Not too long.
Hey, The system is to pull them off a Blackbot. If you can't do that, then send me an email requesting it, and I will reply your email and I'll attach them. That's the deal, all right? Because you're creating more work for me by not doing what you're supposed to do.
It's not my fault though. I sent it to you through email.
Hey, it's not my fault either. Figure it out. All right, here.